lazy today, so y'all just bear with me. We might stop class early. I don't know. Being lazy.
It is Friday.
Yeah, it is. But if I'm ever lazy, I'll have somebody complain, so I can't be lazy too much. But these other teachers, they can do just about nothing and nobody will say a word. I'm lazy one day and people call my department head. I don't see how some of these teachers get away with it. But let's see, I'm just looking at some of the things that, yeah, I need to cover some of this. I guess there's order of operations. We already covered that. I guess we could start right here. Okay, this is still 6.1. So I covered the first part, or one of the parts of 6.1 was order of operations. And today I'm going to cover algebraic concepts. Now, before I even get started, I have a couple of things I want to write down. And that would be, there's several different parts of algebra. There is determine and evaluate. There is simplifying. There is solving. And then there is graphing. Okay. We're going to be covering all of these. I think this is 6.6. We're going to do this one separately. You'll have a separate test on this. Solving and simplifying, that's like 6.2, 6.3, and 6.4, but it's mostly 6.2 and 6.3, those two. And of course, this is 6.1. So there's different parts of algebra. And I just wanted to show you that because we haven't even covered the first part. Technically, right before you go into algebra, you study order of operations. And that's kind of like your last thing of basic math before you go into algebra. So we went over that last time. Now we're going to go over this. And then this bleeds over into that because you got this, and then you got definitions of algebra and, you know, a glossary of terms, and then you move into these two. So we're right here right now, determining and evaluating. Both of these words, I want you to write down, mean, both of these words right here mean plug and chug. Does anybody tell me what plug and chug means? I know somebody or somebody's parents have taught you what plug and chug mean. What does plug and chug mean in mathematics? Oh, come on. You've never heard, y'all been through 12 years of schooling, and nobody has ever heard plug and chug before.
I've only ever heard to say just finish the problem.
I'm sorry, what?
The only way I've ever heard it used is just a teacher saying finish the problem, plug and chug.
Yeah, plug and chug into the problem. In other words, plug in the numbers and what? Chug out the arithmetic. It's amazing to me. And this is not just this class. I'm like, I heard that all the time when I was growing up. I guess, you know, I guess there's just nothing to teach today except for things that really don't matter. So anyway, I'm going to shut up. Plug and chug. When you see this in the directions, that means you're going to plug and chug. Now, how do you know the difference between the two, determine and evaluate? Well, I'm going to show you that next. Here is what the directions will say with evaluate. Evaluate the following. It'll say something like that. I have been missing some of my markers, like this marker is a good marker, and I just found it. I found a whole handful of markers. Why am I telling you this? Because I went on a cleaning spree right before class, and I mopped because I saw one of my markers behind the trash can, but here in the mudroom. And I pulled the trash can out, and there was like 10 markers behind the trash can. My cats have been knocking them off of my table here in the breakfast room, and one of them, I hadn't figured out which one, has been putting all of my markers behind the trash can. So I found a whole stash of markers behind the trash can. I hadn't figured that out yet, and nobody's going to say anything.
They're very skilled hunters.
Yes, they are. To hunt down and track a Sharpie, that's real, you know. I got one cat, his name is Domino, and he takes socks out of my mudroom where I wash my clothes, laundry room, mudroom, whatever, and he will walk through the den like he has just caught a mouse or a rabbit or whatever, and he's got a sock in his mouth. They're weird. All right, evaluate. And it'll have something like 2x plus 3y. And x is equal to 2, and y is equal to 4. And this is the way the question will look. And this means plug and what? Plug and chug. X is 2, and y is 4. 2 times 2 is 4. 3 times 4 is 12. 4 plus 12 is 16. That is a test question. Now, you probably only get one on the test because I can tell you right now, 6.2, 6.3, and 6.5, I think, is going to make up 80% of your test. But I'll tell you that later. 6.1 is just going to make, and you got 2 tests. You got 6.1 through 6.5, and that's one test, and then you're going to have 6.6 as a separate test. But this is one test question on the test. And everybody in here should be like, oh yeah, I remember how to do that. So what is determine? Well, determine is the same thing, only determine says something else. It says determine if the following is true. And they'll do something like 2x plus 3y is equal to 7, and x is equal to 2, and y is equal to 1. Everybody with me?
Yep.
Yes, Hubert. Thank you. I appreciate the one person that's interacting with me. Thank you, Miss Roberts. Was that Miss Roberts?
Yes.
Appreciate it. One day you'll have a nice office. All right. 2 times parentheses plus 3y is parentheses is equal to 7. Plug in a 2 here and a 1 here. 4 plus 3 is equal to 7. True or false?
True.
True. So this one would be true. If it came out with 4 is equal to 7, that would be false. So these are one question. These are 2 questions that are on the test. One will say evaluate. Evaluate means plug and chug. Plug and chug, but you don't have an equal sign. All right. Evaluate means plug and chug, but you don't have an equal sign. Determine means that you have an equation and you have to check to see if it's either true or false. So that's the difference between the two problems. And that takes care of determine and evaluate. Now we're going to talk about some definitions of algebra. Okay, algebra is mathematics undone. I'm going to show you what I'm talking about.
So is this in stuff in the next section?
This is 6.2. No, this is still 6.1. So I haven't got, see, that's why I keep showing y'all this. This is 6.1. We're in definitions right now. Pay attention, Mr. Pack. All right.
Well, remember, I had to go check on something.
I know, I'm picking at you. All right, so what is algebra? Algebra undoes mathematics. Two plus 3 is equal to 5. 5 minus x is equal to 2. See, this is a mathematical sentence. This is an algebraic sentence. Okay, so you need to be able to tell the difference between the two. Algebra undoes mathematics. This is blurry. I have it set on auto, and auto sucks. I don't know how to fix it. There, that's a whole lot clearer. Is that better? Yeah, Hubert, that's better. Thank you, class. Thank you for the input. All right, so this is a mathematical sentence, and this is an algebraic sentence. An algebraic sentence has a variable in it. A variable is a letter that signifies or symbolizes the unknown. Now, a lot of people can say, well, heck, that's easy. Or let's say 5 plus, yeah. 5 minus x is equal to 2. Yeah, x is equal to 3, basically. And a lot of people, you know, redneck attitude, well, I know what that is. That's just 5 minus 3 is equal to 2. Okay, yeah, but that's with a Mickey Mouse problem like this, all right? This is not very high on the rocket science level, all right? This is like first grade stuff. So, you know, what you're training yourself to do when you do algebra is to take a problem apart, undo it, put it back together, and get a solution. That's what algebra does. It trains the problem-solving process of your brain. Okay? It's not to complicate things, and it's not to do things that you'll never use. No, it trains. Algebra trains the problem-solving process of your brain. Algebra and calculus. That's what algebra and calculus does. Now, if you want to take the redneck disorder and say, well, we never going to use this, well, you're missing the whole boat. Everybody needs to have a couple of semesters of algebra or calculus or whatever the case may be to train the problem-solving process of the brain. We all know that a creek starts off as a little trickle. And the water goes like this. Over time, that water cuts away and cuts away at the earth, and eventually you have a big creek that's cut, and you have like, you have like sides or banks, and that water has cut, and as it cuts and it cuts into the earth, it gets faster and faster. Well, this is the problem-solving part of your brain, and you have synaptic brain cells and all that stuff to get, this is the problem that you see, and this is the problem-solving process. And it's just like a creek. After you train it and train it and train it, this gets deeper and wider, and the water runs faster and faster, and it gets bigger and bigger. And that's why you do algebra and calculus, to train the problem-solving process of your brain. So don't be a redneck and don't say, well, we don't use this, because it just shows you ignorance when you say that. All right, so let's go ahead and look at some more stuff. A term. Well, let's go with a big umbrella. And an umbrella has a handle. And under this umbrella, this is called, we can call this mathematics. All right, or no, let's call it algebra. Algebra is made up of terms, equations, expressions, and other things. What is a term? A term is like 2x. A term is like 4 by itself, because technically it has x to the 0 beside it. Everything has a coefficient. This is called a coefficient. Coefficient. I remember my high school teacher used to say that word, and we used to make fun of that word when I was one of those dumbasses in high school that used to be the class clown. Y'all didn't have any of those in y'all's classes, did you? Well, I did. I was one of them. Anyway, to make a long story short, we would always make fun of that word coefficient. Don't ask me why, but we would. And the coefficient is the number that's in front of the variable. There's always a coefficient in a variable. You may not see it, but there's always a coefficient, and there's always a variable. And of course, you see the variable is right here. The term is made up of a coefficient and a variable. Sometimes you don't see the 1, and it is not there, but it's there. You just don't see it. And that'd be x to the 5th power. You know, that's a term. That's a coefficient right there of 1. Sometimes you don't see the x to the 0, because x to the 0 is 1. Anything to the 0 power is 1. So sometimes there's nothing there, but there's an x to the 0 power there. So every term has a coefficient and a variable. And you put 2 or 3 of these terms together, you have either an equation with an equal sign, or you have an expression that does not have an equal sign. Okay? What do you do with an equation and an expression? Well, an equation, you solve it. And an expression, you simplify it. We're going to get into equations here in a little bit, but an expression, you simplify it. And I'll show you an example of that. Question on these.
All good.
I'm sorry, say again.
Said all good.
Got it? All right. And that's what they're telling you in these slides right here. All right. A constant is another word for a coefficient. You could say a constant is going in front of it. A constant is usually by itself, though, like 5. But I could easily say 5. You know, I could, if you say, well, Hubert, 5 by itself, that's a constant. Yeah, or I could write it as 5x to the 0. And here you have a coefficient of 5 and a variable of x to the 0. And that x to the 0, since it's 1, is not shown. So you could say this is a constant, or you could say it's a coefficient. Either way, I prefer calling it a coefficient, but that's just me. These are expressions, as you see, they have no equal signs, and we'll get to simplifying those later. We're not going to simplify them right now. These are just terms. Terms are, there's a term, there's a term, there's a term. This one has 3 terms. This one has just 1 term, 4x. That's it. 4x is a term. Okay? Like terms and unlike terms. Like terms, I'll give you an example of like terms. Like terms. 2x and 4x. Those are like terms. 3y and 6y. Those are like terms. 2x squared and 5x squared. Those are like terms. Think of these variables as labels. 2 boxes of cereal and 4 boxes of cereal. Now, if I add or subtract 2 boxes of cereal and 4 boxes of cereal, am I going to get 3 cans of paint? No. If I add boxes of cereal and boxes of cereal, I'm going to get what? Boxes of cereal. I'm not going to get cans of paint. So that's what like terms are. Like terms are like labels. This is a label, and that's a label. Okay, the X tells you that this is 2 boxes of cereal plus 4 boxes of cereal, or 2 boxes of cereal minus 4 boxes of cereal. Here's the cans of paint. 3 cans of paint and 6 cans of paint. 2 quarts of milk, 5 quarts of milk. These are labels. They're called variables, but they're also called labels. And if you add or subtract labels, when you add or subtract labels, you're going to get labels. Same thing with multiplying, but I don't want to do that with multiplying. I just want to do it with addition and subtraction. So these are terms, and unlike terms would be just pretty much self-explanatory. 2x and 3y. Those are unlike terms. 4x squared and 3y squared. Those are unlike terms. 3 star and 5 box. Those are unlike terms. So you always look at the variables as far as the application of like terms and unlike terms. There's the word evaluate, plug and chug. Now I'm going to let you write down the examples that they give you here. And I'm looking, okay. Oops. There is an example. So I want you to write down that example. And now I've given you 2 examples of evaluate. And I want you to do this one. I'm going to write it down while you're writing it down. Negative x squared plus 3x plus 10, and x is equal to 2. All right, give y'all about 30, 45 seconds to do that one. And if you can't do it, then we'll just write it down as a failure. Oops. There we go. All right, first thing I'm going to do is I'm going to rewrite everything with a set of parentheses. Now I'll tell y'all a secret. I've got several degrees. I got most of my teeth in my head. And I also have running water in my house. But I still use parentheses when I plug in something. Why do I do that? Why do I use parentheses whenever I plug in something? Does anybody have any idea why I do that?
It helps with confusion.
Exactly. It helps decrease confusion. But I have people that don't use parentheses. Remember, I've got several degrees. One of them's in mathematics. I've got several degrees. I've got most of my teeth. And I have running water. And I use parentheses, but some of you students that don't have a math degree and you've always had trouble with math or algebra, you don't use parentheses. So what's wrong with this picture? I think you need to start using parentheses. So plug in a 2 here and plug in a 2 here. Now the reason I tell you that is because there are those people out there, and I hate to say this, but they're mostly guys. They think they don't need parentheses. Hell, they don't even need this class because they already what? They already know it. You ever met somebody like that, girls?
Oh, yeah.
Yeah. It's usually males. Let me tell you. -4 plus 3 times 2 is 6 plus 10. Now, I want to be fair. I'm only talking about 60 to 70% of the male population. There are some males out there that aren't stupid until they're 35 years old.
Yeah,
But-
I parentheses.
I'm sorry, what, Mr. Pack?
I said I do parentheses.
Good job. -4 plus 6 plus 10. But you still have 40-year-old guys that cruise the mall. It's really sad. They kind of like those, remember those dance recital people I told you about? Those moms that try to dress and act like their teenager daughters? It's real sad. The male counterpart to that is the male that still cruises the mall at 40 years old. Don't act like you don't know what I'm talking about. Some of y'all know exactly what I'm talking about. All right, -4, you owe $4. You have 6. You have 2. You have 2, you have 12, you have 14. So your answer is 14. Wait a minute. Nope. I'm doing things in my head. Sorry. 12.
That should be. I was about to say.
I was doing it in my head while I was doing it out loud, and I got 12 right there. Sorry. Okay, question. That is another test question. And for those of you that didn't use parentheses and you believe I'm wrong, there's the answer. And yours is wrong, so that means that your way is broke, so you need to fix it. Now let's see if I got a determine in here. There's a determine. All right, do that one. And that will conclude pretty much the 6.1 section, except for order of operations, which we've already covered, I think, unless they put something new into 6.1. Determine whether 2 is a solution to the equation 3x squared plus 7x minus 11 is equal to 15. First thing I'm going to do is I'm going to rewrite using parentheses. Oh, there are other reasons besides lessen the confusion. Anybody have any idea why else I use parentheses? Besides, it decreases confusion.
And all that.
I'm sorry, what, Mr. Pack?
It helps with like the order, like how you do things. Like
It helps with the order, yes. That's one of the reasons. And then there's also 2 things that y'all can't stand besides word problems. What are the 2 things in mathematics that y'all can't stand besides word problems? Oh, come on, people. What in mathematics can you not stand? You always reach for the calculator. Huh?
I can't stand mathematics in general. So.
Oh, come on. You don't like adding money?
No.
Okay. Well, you're strange, Mr. Pack.
I
Because
hate
everybody likes adding money together. But you're tough. You can take it. All right. So what are the 2 things in mathematics? Miss Roberts, what do you not like in mathematics besides word problems?
To be honest, I don't like anything with algebra.
Okay, I'm thinking of mathematics. I'm thinking of basic math. In fact, we've already covered both of them in chapter 5. And it's not scientific notation. So what are the other 2 things that y'all hate to deal with besides word problems?
The fractions.
Fractions, and what was before fractions? 5.2. Negatives. That's the 2 main reason I use parentheses is because of fractions and what? Negatives. See, if I plugged in if this was a -2, that whether -2, I'd have to plug in a -2, and those parentheses help decrease the confusion. That's why I use parentheses. If you walk up to me here at my house and say, Hubert, I got a problem I'm trying to do for work, will you do it for me? And the first thing I'm going to do is use parentheses wherever I can. But some of y'all don't need to because y'all invented mathematics. So anyway, 2 and 2. 2 times 2 is what? What's 2 squared?
4.
4. I think you said 4.
I did.
Plus 7 times 2 minus 11 is equal to 15. What's 3 times 4?
12.
Thank you. Appreciate the interaction. 12 plus 14 is 26. And 26 minus 11 is What do you notice about the way I did this problem? What do you notice about this?
You did the first part of it first.
I did the first part, and then I did what? I did it what? Blank by
You did
blank.
it
What
like
did I do?
over and across. Is that what you're asking? Like you
I did it blank by blank. What did I do?
right?
Step by what?
Step by
Step by step. This is what some of y'all do. Have your notebook paper lines right here, especially the guys. This is what y'all do. 3x squared plus 7x minus 11. And then y'all do some writing over here, and then you do this, and then you try to get 11 or equals 15 equals 15. And this is what y'all do. Y'all try to do it in one line. You're not that smart. Stop doing it. Next. Let's see if they got order of operations in here. Are we going to, I think we're going into, yeah, we're going into algebra. I thought that was 6.2. I guess it's not our 5.2. Well, darn, they put all of algebra in 5.1. Wow. Or 6.1. I didn't know is this a new book? Does anybody know if this was a new book? I think it was. I think this book is new because they used to not have algebra in 6.1. So we're going to stop there. I'm going to stop there. And that's 3/4 of the way through chapter 6.1. This is what I want you to do for homework. I want everybody in here. I want you working on 6.1 homework. Now, if you want to go past into the algebra problems, that's fine. If you want to stop at the algebra problems, that's fine. But I want you working on it. Does that mean that you have to finish it by Monday? No. I want you working on 6.1 homework. Go as far as you can, and if you want to stop at the 2x plus 3 is equal to 7, and it says solve, if you want to stop there, stop there. If you want to try to do as many as you can, fine. But we will finish 6.1 Monday. Does everybody understand that?
Sounds good.
All right. So, I mean, you really don't have to do anything this weekend. You don't have to work on 6.1 because we haven't finished it. But if you want to start working on it, I would highly suggest that. Does anybody have any